Good morning. Today we are starting our book number 3, working on our next unit having to do with angles and shapes. So we are doing CO51 to get us started. I can measure, draw, and classify angles using a protractor. So the protractor is this lovely tool that we see. You will be using protractors that look like this. And we are going to talk about how we use them to do measurements of angles. So you can notice that it measures from 0, and even though it's not written always on the protractor, it might not have the 0 listed, but we know at the very bottom it's 0. It goes from 0 all the way to 180 on the right, going to the right. And on the inside, it goes from 0 to 180 going to the left. So on the outside, it goes to the right. On the inside, it goes to the left. This is so you can measure angles that open to the left and that open to the right. So depending on which way the angle opens, depends on which set of numbers you use. So we're going to talk about that in a minute. But first, let's get some definition of some of these types of angles that we are going to be doing. First, there's the vertex of an angle. The vertex is the point where two sides of an angle meet. So right there, where the top side meets that bottom side, the point is called the vertex. An acute angle is an angle with a measure of less than 90 degrees. And we put that little degree symbol there to show that we are talking about an angle. So an acute angle is acute and little. So acute means acute little, less than 90 degrees. An example of what that might look like would be an angle like that. We can see the vertex is here, and we can see it's a little angle. If it's a right angle, that right angle is an angle with a measure that's exactly equal to 90 degrees. So it looks like this. And there's the vertex, and a lot of times you'll see a little box in there. And that's to show that this is exactly a right angle. It is exactly 90 degrees. Now, I drew this by hand, so it is not exact. But if I put that box in there, even though it doesn't measure exactly because I freehanded it, we know it represents 90 degrees. So the acute angle is less than 90 degrees. It's going to be smaller than the straight up and straight across. Our next angle is an obtuse angle. And an obtuse angle is an angle with a measure greater than 90 degrees. So we know that right angle was 90 degrees. Acute is smaller, so an obtuse angle is going to look bigger than that 90 degrees. So little, cute and little, exactly 90 degrees is that right angle. Bigger than that 90 degrees is the obtuse angle. One more angle for us to talk about, and that is a straight angle. A straight angle is an angle with a measure that is equal to 180 80 degrees. Now, if we have a right angle is 90 degrees going one way, and there was a right angle going the other direction, 90 plus 90 would equal 180 degrees. So that's how we can say that straight, imagine that this is a perfectly straight line. A straight line is a straight angle, and it is exactly 180 degrees. So the straight angle, we can imagine that it's two 90-degree angles next to each other. 90 plus 90 is 180. So two right angles would equal a straight angle. So it's important that we know the definitions of our different angles, because we're going to be classifying angles. We're going to have to know, first we're going to have to know how to measure them to see if it's acute, a right, an obtuse, or a straight angle. Then we're going to write it out. So we're going to measure it, and then we're going to classify it, giving its name. Now, a lot of times people say, oh, I can just look at an angle like this and say, oh, that's 90 degrees. It looks like it. Just because it looks like it doesn't mean we can assume it, because we have to actually measure it. Unless if there is a box, we can assume, if there's a box, that it is exactly 90 degrees. If there is no box in the corner by the vertex, we have to actually measure it, because 89 degrees looks really similar to 90 degrees, but it's not. So we have to be careful. You don't ever make a guess with math. All right, we measure everything out. Last unit, we were working on slopes, and I told you, you have to count out your slope. You can't just look at the line you drew and make a guess on what the slope is. You actually have to count it out. Same thing with the angles. You actually have to measure it. So let's look at how we're going to measure our angles. So we're going to use our protractor. It says to measure an angle with a protractor, position the vertex of the angle, that point of your angle, at the center of the protractor, making sure the bottom of the angle is flat along the bottom of the protractor. So let's see what that looks like with our protractors. I'm going to show you on the back side with a blank page so we can see it without all those numbers. So here is my vertex. I'm going to take my protractor, and with the protractors we have in class, there is an open hole right here. That's what we line up with our vertex. So we can see, let me get it so it doesn't have a glare. You can see where that vertex point is and that open center in our protractor. And then you can see how there's this line here with on the protractor. You're going to line up the bottom line of your angle with that line in the protractor. So I'm going to be as precise as I can, get that point right in the middle of my circle, and I'm going to try to make that black line exactly on my angle line. Now, to know which number I'm going to use, am I going to use the outside numbers or the inside numbers? I go to my point, my vertex, I follow the angle line over to the side to where the 0 is. On the inside, I can see it says 150, 160, 170. It's not written, but we know that's a 180 right there. So I don't want the inside numbers because that's 180. I want the outside numbers where I see that 0. So for this angle, I'm going to use the outside numbers, and I'm going to come all the way around until I get to where this other line of the angle is. And I can do extending that line. And I can say, okay, I'm on the outside numbers going higher. And it looks like it might be, maybe 128. I'm guessing 127. So it's hard to know exactly where it is. I would say this is probably the 127. So I would call this 127 degrees because it's less than 130. I know it's greater than 125. Because I'm having to extend it myself, I might not be exact. I accept within a few degrees. So if it looks like 127 to me, if you were to write 128 or 126, something that's really close, I would accept it. If you wrote 120, no, it's not anywhere near 120. If you were to write 135, no, it's not anywhere near 135. So you have to be close, within a degree or two. If you were to have gone from the inside numbers and come up and you said, oh, that's a 52, well, no, it's not 52 degrees. I know it couldn't be 52 degrees because look at my angle. This type of angle is an obtuse angle. It's big. It's bigger than 90 degrees. So my angle measurement has to be bigger than 90 degrees. If I put it was that 52 degrees, that's an acute angle. That's smaller than 90 degrees. So that's your checkpoint. Does your angle measurement match what you're classifying it as? If you can look at this and say it's obtuse, it is bigger than 90 degrees. 90 degrees would have been straight up and down. It's obviously bigger than that. I know it's obtuse. I need to make sure my measurement matches that it's an obtuse measurement greater than 90 degrees. So if like I said, if I would have put 52 degrees, that doesn't match. 52 degrees would not be an obtuse measurement because 52 is less than 90 degrees. So let's look at our angle on our paper, and I want you to practice matching up. Mrs. Larson should have protractors. I have a class set of protractors that we can use. There might be one or two of us that have a protractor from home with us. You can use yours. It might be set up a little different. You might not have the hole in the middle like ours do. You might have to put it down at the bottom. But if you have a hole in the middle like the class set, you're going to match up that hole with the vertex. So put that vertex right where that hole is and then match up this line on the protractor with that bottom line on your angle. Then remember what I said, you go from that vertex, you follow that bottom line to tell you which set of numbers you're going to do. Are you going to do the inside numbers or are you going to do the outside numbers? Now they have the protractor on the paper. We can see how they extended that angle line. So they extended the angle line here. So we can see that they got 50 degrees. And I want you to see, or sorry, not, this is really small for me to look at. Not 50 degrees. 50 degrees would have been up here. So 45 degrees. So if we extended that on our protractor, we would see how it goes up to that 45 degrees on our own protractor. So see how they extended it to the 45 degrees on the paper. You extend it to the 45 degrees on your paper. I want you to get practice using a protractor. Key steps that we have to follow. Step 1, line up your vertex with your protractor. the class set of protractors, we use the hole in the middle and we put it directly on top of the vertex. Then you line up the line on your protractor with the bottom line of your angle. Follow step 3, that was step 2. Step 3 is to follow that angle line out to the 0. In this case, the 0 is on the outside of our protractor, so we follow those numbers on the outside. So that was step 3. Step 4 is follow where that top line of the angle goes on your protractor and write down what angle that would be. So this ended up being 45 degrees. If the angle doesn't reach the degree measure, just visually extend the angle. What is the measure of the angle shown? We just saw the 45 degrees. Then it says, what is its classification? Now be careful with this because on the test, it will say, do the angle measure and classify it. So you have to write, is it an acute angle, a right angle, an obtuse angle, or a straight angle? So if we look back at those angle definitions, I know if it's less than 90 degrees, it's an acute angle. So I would write acute. Okay. So now it says measure each angle and classify it. So I need a measurement and a classification. Is it acute, obtuse, or a right angle? When we look at this first angle on here, our first step, remember, so step 1, line up the vertex. Step 2, line up the bottom line of the angle. Step 3, follow the bottom line to the 0. So that's going to tell us, is the 0 on the inside or the outside of our protractor? Do we want to go all the way to that outside and do the outside numbers, or are we stopping on the inside and doing the inside numbers? Then follow the top line to the measurement. So if we look at our first angle, my first step, line up the vertex. So I'm going to go to that vertex right here, and I'm going to line it up with that center circle. Then second step, line up that bottom line. So I want to make sure it directly covers the line on my protractor, directly covers the line on the angle. So the line on the protractor covers up, there we go, covers up the angle line. Third step, I'm going to follow that bottom angle line over to the 0, which on our class protractors, it's not listed, but we can see the 10, 20, 30, 40 on the inside, so that means the 0 is on the inside that we're going to hit. Then our fourth step, I'm going to follow that up to where that top line hits the protractor, and I'm going to look at that measurement, 10, 20, 30, 40. I don't get to 50. I am below 50. So I would call that maybe 48 degrees. So I would accept 48, 49, maybe 47, 46, somewhere in that area. So that was my first step, was measuring it. Now I have to classify it. If it's 48 degrees, look at my angle definitions. 48 degrees is less than 90 degrees. So it is acute. So you must have the angle measurement and the classification. So you're going to do the other 3 on your own. You're going to practice measuring it, lining up your vertex. Then you're going to line up that bottom angle, the bottom line, not the bottom angle, the bottom line. Then you're going to follow that top, or follow it to that 0. So you know, am I on the inside numbers or the outside numbers? If our angle is going this way, we're using the outside. If our angle is going this way, we're using those inside numbers. Then you're going to follow it up to where that top line of the angle hits the protractor and write down that measurement. Last step is to classify it. On the test, I always have people who forget to classify. Don't forget to classify. So do these 3 angles yourself. Then on the bottom, it says, using your protractor, draw a 30-degree angle and a 110-degree angle. So to draw your own angle, you're going to draw your own vertex. You're going to draw your own bottom line. Then you line up your protractor, vertex, and that bottom line, and you look to see, where is my 30 degrees? 30 degrees would be right here. So I'm going to put a point, a dot, right where that 30 degrees is. And then I'm going to lift up my protractor and I'm going to connect my 2 points, my vertex with the 30 degrees. And then I'm going to label it, proving that I know this is the 30 degrees, not the 110 degrees. Then you're going to go over onto this space. You're going to draw your vertex, draw your bottom line, and then you're going to draw the 110 degrees. So you line up your protractor on top of the vertex and the bottom line. You put a point where the 110 degrees is. You pick it up, use your protractor to connect your dots, making sure that the 30-degree angle is acute and little. So you want that little angle, making sure that the 110 degrees is obtuse, bigger than that 90 degrees. Okay, so practice drawing that 30-degree angle. I showed you how to do it. Use that same knowledge to draw a 110-degree angle. It is okay to ask for help. A lot of times kids aren't totally comfortable using the protractor. So Mrs. Larson's going to be walking around making sure we're lining it up correctly. You do not need to have your own protractor. We have our class bucket. We don't need it much in this unit, so I don't require us to have one for the whole year. We have the class bucket, so we'll use the class bucket on the objectives we need them on and on the test. If you have your own, totally fine to use your own. Make sure you know it. Like I said, the class bucket, we have a hole. Not all protractors are set up the same way. So figure out how your protractor works if you are using a different one. When you are done with the protractor, you're going to turn it back in to the class bucket. We do have Khan Academy that was assigned yesterday. Work on your Khan Academy. We have packet number 8 that is due on Tuesday. Get your packet number 8 done and turn it in today, and you'll have a chance to fix mistakes on Monday. Remember, no lates for that packet number 8. It is the end of the trimester. I hope you are well. I hope to see you soon. Have a wonderful day.